Good evening, students. How are you all? So, in the last class, we have started the chapter probability, and we have done two types of question basically on the probability. One is based on the coins, and second one is based on the that dice. Okay. So today we have to do the last section of the probability, in which we will learn like the questions based on the concept of cards, the playing cards, and some sort of questions of geometric probability that we will learn today. So let me revise you what we have done so far. So basically the probability of any event. So probability of any event is given by number of favorable outcome over total outcome. This was the basic formula in the probability which we will use in the entire chapter, and we have done for the coins. So, and the total number of outcomes in a coin was 2 power n, where n belongs the number of coins. If there is one coin, total outcomes are 2 coins, total outcomes are 4, and so on. Similarly, we have done the dice. In the dice, we have done the questions on 1 dice and 2 dice. So, the total number of outcomes in a dice is 6 power n, where n is the number of dice. If we roll 1 dice, the total outcomes are 6. If we roll 2 dice together, the total outcomes are 36, and 3 dice for 6 cube, which is 216. Okay. So, before starting, so let us revise one of the question. Try this question, all of you. If X is chosen random from numbers -2, -1, 0, 1, 2, what is the probability that x square is less than 2? This is the question. X is chosen randomly from the given numbers -1, -2, 0, 1, 2. We have to find the probability that x square is less than 2. Good evening, Itanagar. That's correct answer. Sisipur, what's your answer? That's right. Perfect. So x square should be less than 2. So what are the numbers we should pick? If you pick -2 square is not less than 2. So x can be -1, because -1 square is less than 2. It can be 0. 0 square is also less than 2. It can be 1. 1 square is also less than 2. So favorable outcomes are 3 and total outcomes are 5. So probability of the event is favorable outcome upon total outcome 3/5 or 0.6. Either you can give your answer in decimal also. Okay. Try the second question. It is given x is selected from 1, 2, 3, and then second number y is selected from 1, 4, 9. Probability that product of x and y is less than 9 is x is the number which we are selecting from 1, 2, 3, and the second number it is selected from 1, 4 and 9. What is the probability that the product of x and y is less than 9? First of all, find what is the sample space, what must be the total outcomes. That's right, Itanagar. Not 5 by 6. Sisipur, see, when we will find the total outcome, here 3 possibilities are for x and 3 possibilities are for y. So how many possibilities for the number xy? So for every possibility of x, there are 3 possibilities for y. Like if we write x, if we draw the branching diagram which we have done in the last class, the possibilities for x are 1, 2, 3. Now for each possibility of x, for 1, there are 3 possibilities for y. It can be 1, 4 or 9. Similarly, over here it can be 1, 4 or 9. Similarly, it can be 1, 4 or 9. So the ordered pair which we can get is either 1, 1, 1, 4, 1, 9, 2, 1, 2, 4, 2, 9, and 3, 1, 3, 4, and 3, 9. These are the total possible outcomes when we pick 2 numbers out of this 1, 2, 3 and one of the number from 1, 4, 9. Now, so total outcomes are 9 and we have to find the probability that product is less than 9. So less than 9, we have to multiply both the number and we have to see which one is giving the number less than 9. So we can see 1 into 1 is less than 9, 1 into 4, 2 into 1, 2 into 4 is less than 9, 3 into 1 is less than 9, and only these are the cases in which we are having the number less than 9. Rest of the things we are having the number greater than 9. So the favorable cases are only 5, total cases are 9. So probability is 5 by 9. That is the answer. All of you are getting it? Is this clear to all of you? Okay. So let us start with the next section in this one based on the cards, because right now till now we have done the questions based on the dices and on the coins, and now we will learn the concept of the cards, then we will practice the questions. So cards are basically the playing cards. So how many have you played the cards, Sisipur and Itanagar? How many of you have play or do you play cards? Okay, Itanagar, so you must be know about everything. So you all of you know the names in Hindi or in English? Itanagar? Okay, so let us discuss that cards. So you know, all of you know that we have 52 cards, a set of 52 cards we have. and these 52 cards are divided into 4 sections. Those are known as suits. So in 4 suits we have to divide them, and 4 suits of 13 cards each. Now the 4 suits, name of the 4 suits are, first one is, we can say, heart, and it is in the shape of heart like this. This is the heart card. Second one, we have diamond. It is again a shape like this. Then we have club. The shape of the club is this one. And in the last we have spade. The shape of the spade is this one. Spade, heart, club and diamond, right? So now in these 13 cards of each, in these two, the heart and diamond, as you can see, these two are red color and these two are black color. So we can say in 52 cards, we have 26 red color card and 26 black color cards. Now the further notations in these cards are, so each of the 13 cards have the same set of cards, only all of them are heart, all of them are diamond. So in those 13 cards, we have number cards and face cards. So number cards starting from 2, 3, 4, 5, 6, 7, 8, 9 and 10. After 10, we have jack, then queen, then king and then ace. So these are the 13 cards. In these 13 cards, these cards, as you can see, from 2 to 10, these are called number cards. So in a group of these 13 cards, we can see 9 are the number cards. So total 36 number cards are there. Similarly, these jack, queen and king, we can see a face of some person is there on these cards. That's why they are known as the face cards. And if we come, so total in each suit there are 3 face cards, so total of 12 face cards are there. And if we combine jack, queen, king and ace all together, that makes honor card. If we combine all 4 of them, that is known as honor card. So total of 16 honor cards are there, total of 12 face cards are there, total of 36 number cards are there. So only this information is there, and based on this one, we have to solve the questions based on probability. Now, again the same concept. In the last class, you remember that I have told you 2 words. One is the and one is the or. So and or. And means common, and or means total. Like suppose if we have a number from 1 to up to 50, right? And we have to find the if we are picking one of the number, what is the probability of picking a number which is a probability of picking a number multiple of 3 and 7. So 3 and 7 means it should be a multiple of both 3 and 7. It means it should be, so what should be how many numbers should be there? Multiple of 3 and 7 both. So multiple of 3 and 7 is nothing but the LCM of 3 and 7. So first of the number is 27. Oh, sorry, not 27, 21, 7 into 3. After that we have 42. And out of these 50 numbers, only 2 numbers are there, 21 and 42, which are the multiple of 3 and 7 both. So here and indicates common. So it should be of both of them. So only 2 of the favorable numbers are there. So probability is favorable outcome upon total outcome, which is 2 by 50, which is 1 by 25. If we have written like this, multiple of 3 or 7, It means it can be a multiple of 3, it can be a multiple of 7, or it can be a multiple of both of them. So multiple of 3 in 50 are something like 16 multiples will be there, because 3, 6, 9, 12, and then 15, 18, 21, 24, 27, 30, this 33, 36, 39, then 42, 45, and 48. These are the multiple of 3. Then multiple of 7 are, so total these are the 16 multiples. Multiple of 7 are 7, 14, 21, 28, 35, 42, and 49. 7 multiples are there. But we have to make sure the total multiples of 3 and 7 are 16 plus 7. But we can see some of the multiples are repeating. So what we'll do, whatever is the repeating, we have to take it only once. Like we can see, this 21 is common in both of them. 42 is common in both of them. So total multiples of 3 and 7 are 16 plus 7, which is 23. But we will count this 21 and 42 exactly once. So we'll subtract 2 of them. So 16 plus 7 minus 2 we will do. 16 plus 7 minus 2, which is 21 multiples are there of 3 and 7, 3 or 7. So probability will be 21 over 50. That is the answer. Is this clear till now? The difference between and or we have done in the last class also. This is very important because this words plays a major role in solving the question. Any doubt till now? Itanagar, CC4, any doubt? Okay. So let us start with the question based on the cards. It is written one card is drawn from a pack of 52 cards. You can see, okay, once more I have to explain. Which one you want me to explain, that example or the concept behind the cards? Itanagar? Okay, see, and or basically, and means common. Common means it should satisfy both of them. जैसे अगर हिंदी में हम बोलें तो and का मतलब हुआ कि दोनों एक साथ होने चाहिए. And or means total. It can be any of them or both of them. Or also means at least. Or means at least one. So if I am saying A or B, it means either A or B or both of them. So at least one indicated by or, and at a time both of them, that is indicated by and, or you can say common region. So multiple of 3 and 7 means it should be a multiple of 3 and 7 both at a time. Like if we pick 6, 6 is a multiple of 3, but 6 is not a multiple of 7. So we can't include 6 in multiple of 3 and 7. But if we see 21, 21 is divisible by 3 as well as 7 also at the same time. So 21 is an example of multiple of 3 and 7. Similarly, 42 is the only number less than 50 and after 21, which is multiple of 3 as well as multiple of 7 at the same time. That's why it is an example of 3 and 7. But here 3 or 7 means either multiple of 3 or multiple of 7 or multiple of both of them. All will be counted over here. So individual multiple of 3 will be also be counted, individual multiple of 7 will also be counted, and both the multiple will also be counted. That's why we are having so many possibilities over here. This is the difference between and or. Or you can understand with this help of this diagram also. Suppose this is one circle. What we say, suppose in your class, let's take an example of your class. Suppose in a class there are 50 students, right? and if I say that 20 play cricket and 40 play hockey, so total students are 50, but cricket play 20 plays cricket and hockey plays 60. So how is this possible? Total students are 50, but hockey players are 60 and 20 players are of cricket. It means something is common between them. Some of the students are there which are playing both the games. So we have to draw, if we draw it in the diagram, we can draw it like this. This is the circle representing cricket, and there must be another circle which is representing hockey. So those two circles should intersect at one point. So the shaded region you can see, this is known as the common region, or you can say this region is indicated by AND, which is common to both of them. So some players will be over here, that's why it is the total cricket and hockey is going above 50. And if we include OR is indicated by all of them. Like if I say cricket or hockey, so this region, individual and common, collectively will be counted in OR, and the common region will be counted in AND. Is this clear? Itanagar, is this clear, the difference between AND and OR? Any doubt in this one? In the concept of AND and OR? Okay, so let's move ahead. So the question is one of the, and you can see that in most of the questions, in all of the questions we are doing, one of the number is picked, one card is drawn. Why? Because if the question is of two cards are picked or two numbers are drawn, so there will be so many outcomes of there, and that concept you will study in the 11th class. So in the 10th class, all the questions will include one of the card is picked, one of the number is drawn, that thing. So one card is drawn from a pack of 52 cards. So we have to find the probability of the following events. So find probability that card drawn is. So I am writing all the parts. So right now do it on your own. Whatever you think what should be the answer, and then we will discuss. Eight parts are there. So when you are done, just let me know, then we will discuss. Don't write the answers, just let me know because there are so many 8 parts are there. When you are done, I will discuss, you can cross check. Shall we start discussing? Itanagar, CC4. Okay. So first is the ace card. We know we have 4 ace cards. So probability will be 4 by 52, which is 1 by 13. And always give your answer in the simplest form. Red card. We have total of 26 red cards are there. So 26 by 52, 1 by 2. Either red or king. So it can be red, it can be king, it can be both of them. So total red card, how many red cards are there? 26 red cards are there. How many kings are there? 4 king are there. So total of 30 cards are there. But in these 26, we have included 2 kings which are of red color. So that is counted over here also in 26 and in 4 also. So we have to subtract that. So we have to subtract 2. This 2 is subtracting because red king card we are subtracting. So total of 28 cards will be there in this one. So 28 by 52. 7 by 13. So make sure that in red cards, total 26 red cards are there. In those 26, 2 kings of red color are already included. And since we have added 4 king, so we have to subtract those 2 which are repeated in both of them. Red and king. Now here the word and is written. It should be red and it should be king. Both of them simultaneously. So only 2 cards are there, which is the king of heart and king of diamond. So 2 by 52, 1 by 26. A face card. Total of, in each suit there are 3 face cards, jack, queen, king. So total of 12 face cards are there. So 12 by 52, dividing by 4, 3 by 13. A red face card. So red face card, how many red? 2 suits are there of red. So total red face card are 6. 6 by 52, 3 by 26. And then 2 of spades. So 2 of spades, only 1 card is there, which is of 2 of spades. So 1 by 52. 10 of black suit. So we have 2 black suits. So there are 2 cards which satisfy this condition. 1 by 13 is the answer. So how many of you have got all the correct answers? Last one is 10 of black suit. Black suit are the spade and the club. So 10 of club and 10 of spade. So 2 favorable outcomes are there. So 2 by 52. Oh, sorry, my mistake. I have written by mistake 1 by 13 I have written. It should be 1 by 26. Yeah, 2 by 52, 1 by 26. That's right. Is this clear till now? Okay, now try one more question based on the cards. So it is written, king, queen and jack of clubs are removed from total pack of cards, and now one card is picked. Find the probability of getting a heart, a king, a club or the 10 of heart. Just let me know when you are done. Yes, you have to answer. No, no, do it. Then we'll discuss. Okay. So now the question is a little bit different, but a basic one. Total 52 cards we know. Out of these 52 cards, 3 cards of clubs, king, queen, jack are removed. So now total cards are 49. That you have to keep in mind. So what is the probability of picking a heart? So heart are still 13. So 13 divided by 49, that is the probability. King. Now we know there are 4 kings, but one of the king is gone. So now right now there are 3 kings. So 3 divided by 49. A club. What is the probability of picking a club? So 3 cards of club are gone. So total 10 clubs are there. 10 by 49. And the 10 of heart. There is one 10 of heart and 1 by 49. That is the answer. Try this. First one is right. The first question. So we have to find the probability that number selected at random from a group of these numbers will be their average. So total 10 numbers are there and we have to find what is the average of these numbers. And you know how to find the average, sum of all numbers divided by the number of numbers. So average of these number, sum of these number is, this will become 16 plus 9, 25 and 30. So average is sum upon numbers. So sum is 30 and numbers are 10. So average is 10. So it is asking us find the probability that number selected at random will be their average. So 3 is present how many times? 3 times. So 3 favorable outcomes are there. Divided by total number of outcomes are 10. So 0.3 is the answer. Okay, yes, CC4, that's right. Now try the third one. Next question based on the balls. That's right. So picking, there are 5 red, 8 blue, 7 green balls. Total are 20 balls. So we have to find the probability that the ball drawn is either red or blue. So red or blue means total. So total 13 balls are there of red or blue divided by 20. Not green. Not green means again it is going for the first case, red or blue. So again it is 13 by 20. Neither red nor blue, it means it is mentioning towards green. So 7 by 20. Suppose if it is written like this, what is the probability that ball is blue and green? Then what should be your answer? If it is written like ball is blue and green. Itanagar, what's your answer? Probability that the ball is blue and green. Because we don't have any color, any ball, a blue and green 4 by 5. How? See, blue and green means on that ball there should be blue and green color both. But we don't have any ball over here which has green and blue color both. Either it is completely green or completely blue. So favorable cases are 0. 0 divided by 20, that is going to be 0. Okay, I got it. Try this question. A and B are friends. We have to find the probability that both of them will have same birthday, first case, or different birthday in ordinary year. There are two types of year, ordinary and leap. This one is ordinary. Yes, CC4, first part is right. Yes, Itanagar, that is right. The second part. That's right. Because same birthday, it should have same birthday. So out of, since we are talking about the ordinary year, the total number of days in an ordinary year is 365. So since they have to be the same birthday, so out of 365, there should be only one day on which they are having the same birthday. So probability is 1 by 365. Now different birthday, they have the different birthday, it means not the same birthday. So you can apply that logic, total minus probability of same birthday. So 1 minus 1 by 365, which is 364 by 365. A letter is chosen from the letters of word assassination. Find the probability that letter is not a vowel. No CC4, that's, read the question statement carefully. It should not a vowel. No, that's not right. See, total letters in this one are, if you count the total number of letters, that is 13 letters are there. Now, a letter is of, two possibilities of letters are there. Either it is a vowel or it's a consonant. If it is not a vowel, so it means we are talking about the consonant. So how many consonants are there? 1, 2, 3, 4, 5, 6 and 7. Only these are the consonant. So 7 are the consonant and vowel are 6. 6 vowel, 7 consonant. So probability of picking not a vowel, it means we have to find the probability of a consonant. So probability of consonant is 7 by 13. Is this clear? Now try this next question, a very good question. So the question says, a box has 54 marbles, each of which is either blue, green or white. 3 types of balls are there, marbles. So if you are picking one of the marbles, so probability of picking a blue marble is 1/3 and the probability of green marble is 4 by 9. So we have to find how many number of white marbles are there in the bag. We have to find the number of white marble in the bag. Yes, Itanagar, your answer is right. Sisipur, what's your answer? No, Sisipur, your answer is not right. See, uh, since there are total 54 marbles, probability of blue marble is 1 by 3. So what is the probability? Number of blue marble upon total number of marble. So let's say blue marbles are B. So B divided by 54, that is equal to 1 by 3. So from here we can say blue marbles are nothing but 18. Probability of green marble is 4 by 5. Let's say green marbles are G. So number of green marble divided by total number of marble, that is the probability, and that is equal to 4 by 9. So we can cancel out this one 9 6 times. So it is 24. So since total 54 marbles are there, so we can say 18 plus 24 plus white marble, that is equal to 54. So we just have to subtract that. 54 minus 24 minus 18. This is 12. So 12 white marbles are there. Is this clear so far? Any doubt till now? Sisipur, Itanagar, and there is one more school, Nahar Lagoon, Government High School, Nahar Lagoon. Any doubt so far? Okay, so now we'll take a break, and then after the break, we will learn the concept of geometric probability, and we will learn how to solve the questions on the geometric probability. Okay, welcome back students. So now the next section of this probability chapter is geometric probability. Now what do we mean by geometric probability and what is the use of this geometric probability? So basically this geometric probability is used when something like, or you can say the total number of outcomes are infinite. In that case, the picture of geometric probability comes into the picture. Like, suppose if we ask something like, suppose if there is a square and there is a circle inside it, right? And the dimensions of the squares are given. Let's say this is 4 and this is also 4, this side. And the radius of this circle is 3, or let's say 2. So if we are, if you have to drop one coin, or if you have to drop something, so what is the probability that it will lie inside the circle or it will lie outside the circle but inside the square? So if something is lying inside the circle, so there are so many infinite points where it can lie. So we cannot solve it by the method of that empirical probability which we have done previously by finding the total number of outcomes or favorable outcome. So in this case, when the total number or favorable outcomes are infinite, then in that case we use the concept of geometric probability. So the concept is still simple. The formula for geometric probability is again the same. The formula is measure of specific part of region over measure of whole region. So basically here we will deal with the area. Whatever is the specific part, we will find the area of that part divided by the total area. That will give you the geometric probability. So let us start with the question itself. Like, so with the question you will get a clear idea what is happening in the geometric probability. Suppose there is a rectangle. The dimensions is, this is 9 kilometer. This is 6. This is 2 and this is 4.5. So the situation is like this. So the situation is like this. There is a helicopter which got crashed inside the forest. So we have to find what is the probability that it may have crashed in the lake region. So you can see over here, the complete forest is in the shape of a rectangle. So the dimensions are this: 9 kilometers is the length, and this 4 kilometer is the height. So area of the complete rectangle we can find. Now we have to find the probability that it may have crashed inside this lake. So we have to find the area for this region which is covering the lake. So again it is a small type of rectangle. So this entire length is 6, this is 9. So it means this is 3. And this is complete 4.5. And this is 2. So this will be 2.5. So the probability that the helicopter has crashed inside the lake region is area of lake divided by total area. So favorable region is the area of lake. So area of lake, yes, CC4, that your answer is right. So area of lake, length into breadth. So 3 into 2.5 divided by total area, which is 9 into 4.5. So this will get cancelled out 3 times, and we can cancel out this one 5 times, 5 9 times. So 5 by 27, that is the probability. So basically what we are doing, we are just finding the measure, or you can say the area or measure of the favorable region divided by the area of the total region. So let us discuss second one. Suppose there is a circle This is a circle and O is center of circle. Okay. So this is a circle and O is the center, which means AC is the diameter of the circle. So there is a dart, we have to throw a dart in that circular board. So we have to find what is the probability that that dart will hit the shaded region. We have to find probability that dart thrown will hit the shaded region, and give your answer in terms of pi. Because it is a circle, so when you are dealing with the area, pi will be used. So give your answer in terms of pi. No need to substitute the value. Yes, Isipur, your answer is right. Itanagar, what's your answer? Something is wrong in this one. The number which you have written 42, that is not right. See, when we will solve this one, so basically, since we have to find that the dart thrown will hit the shaded region, so favorable region is the shaded region, we have to find the area of the shaded region divided by the total area. So for the total area, it is that's right. So total area is in the shape of circle, so we need to find the area of circle, and for area of circle, we require the radius. So here we can see AC is the diameter, and we know angle in a semicircle is 90 degree. It means this angle will be 90 degree. If this angle is 90 degree, this is 6 and 8. So by Pythagoras theorem, we can say diameter AC is nothing but 10. So radius OC is 5. So area of circle is pi r square, 25 pi. Right? After that, we have to find the area of shade region. It means we don't want area of this rectangle. So area of this ABCD is length times breadth, which is 6 into 8, which is 48. So favorable region is this 25 pi minus 48, and total region is 25 pi. So that is the probability for this one. Now try this question. These are the 4 circles given, and radius of each circle is 1 unit. Suppose there is a square ABCD. So point is selected at random from interior of a square. We are selecting a point at random from the interior region of this square. So what we have to do, we have to find probability that it will be from shaded region. We are selecting, all the circles are of radius 1 unit. We are selecting one of the point from the interior of this square. So what is the probability that the point selected is from the shaded region? And you can give your answer again in terms of pi. Okay, and Itanagar, what's your answer? Itanagar, what's your answer? Point selected, we have to find the probability that it will be from the shaded region. And point is selected from the interior of the square. Okay. Okay, so let us solve. So since the radius of the circle is 1, so this is 1 and this is 1, so the side length of the square is 2. So total area, that is area of a square, which is 4, right? Now we have to find the area of the shaded region. So area of the shaded region is nothing but total area of square minus area of these 4 quadrants, and this is 1 quadrant, 2nd quadrant, 3rd quadrant and 4th quadrant. If we add all of them 4 quadrant, it will become a one complete circle. So favorable area is total minus area of circle, which is made up of these 4 quadrant, and which is area of circle which radius of 1. So pi r square. So area of that circle is pi. So favorable area is this one, total area is this one. So probability will be 4 minus pi over 4, which is 1 minus pi by 4. 4 minus pi over 4, that's right. So it says ABCD is a square of side 6 cm, P and Q are the midpoints of those sides. If a point is selected from interior of a square, find probability that it will be from the interior of triangle APQ. That's right, Sisipur. Itanagar, what's your answer? We just have to find the area of the triangle APQ, divide by the total area of the square, that's it. See how we can solve this one. We just have to find the area of the shaded region. So what we can do, let us name these three regions as 1, 2 and 3. So total area of the square is 36. We just have to find the area for the shaded region. So if we see since ABCD is a square, so all of these three regions 1, 2 and 3 are the right angle triangles, and P and Q are the midpoint. So this will be 3, this will be 3, 3, 3, this is 6 and this is 6. So area of the first region, that is a triangle, so half into base into height, that is 9. Similarly, area for third region is also 9, and area for the second region, that is half into 3, which is 9 divided by 2, 4.5. So total area of 1 plus 2 plus 3 is 18 plus 4.5, which is 22.5 is the total area. 1 plus 2 plus 3. Now we just have to find the area for this blue one. So what we can do, from total we can subtract it. Therefore shaded region is 36 minus 22.5, and total we know it is 36. So probability will be 36 minus 22.5 divided by 36. Now 36 minus 22.5, we can simplify this one. So it is 13.5 divided by 36. So we can simplify this one. 135 divided by 360, and by 45 we can divide 45 3 times, 45 8 times. So 3 by 8 is the probability. Is this clear to all of you? Itanagar? Is this clear, Itanagar? Sisipur, is this clear? Okay. So this was all about in the probability. So we have done all different types of questions in the geometric probability, and the theoretical probability we have also done. Okay. So this was the over. Now one question. Not from the probability, but from our previous topic. Let's see how much you remember. I am asking one question from the coordinate. Just do this question. Three vertices of a parallelogram taken in order are these three. Find the fourth vertex. Solve it quickly. It's a easy one. Three vertices of a parallelogram are given. No CC4. That's not right. These three vertices are in order. Which concept of parallelogram you will apply? Use the concept that diagonals of a parallelogram bisect each other. So use the concept of the midpoint. This is a parallelogram, and taken in order means in whatever order these are written, these has to be either clockwise or anti-clockwise. So if you are taking A as -1, 0, then B can be 3, 1, and C can be 2, 2. So we just have to find D, X, Y. I have taken it in the anti-clockwise. You can take it in the clockwise also, but make sure it should be in the order. So we know that in parallelogram, diagonals bisect each other. Bisecting each other, how we can use the midpoint of the diagonal AC will be same as the midpoint of diagonal BD. So midpoint of AC will be equal to midpoint of BD. This is the way in which we will solve this one. So what we will write? Midpoint formula is x1 plus x2 divided by 2. So AC, midpoint of AC is minus 1 plus 2 divided by 2. This is for x. And for y it is 0 plus 2 divided by 2. For BD it is 3 plus x divided by 2 and 1 plus y divided by 2. Now we can compare the x and yes Itanagar, now it's right. We can compare the x and the y coordinate. So if we compare this x from both the side, we can say minus 1 plus 2 is 1 by 2 is equal to 3 plus x by 2. So from here this 2 and 2 will get cancelled out. So x will be equal to minus 2. If we compare the y part, this is 2 over 2 is equal to 1 plus y over 2. So y would be equal to 1. So the coordinates of the fourth vertex is minus 2 comma 1. This is okay. Use the wrong formula. See, so our syllabus is about to end. Only one chapter is left, that is the statistics. So I suggest all of you that you should go through all the previous chapters, start revising all the chapters, and if you have any doubt in any of the topic or so any question, you can send that question over the WhatsApp, or if you want me to revise any of the concept, you can also let me know on the WhatsApp, so that we will do that revision of that particular topic in the upcoming classes after finishing that part statistics. So now I hope this is clear to all of you. Okay, so this probability chapter is finished now. In the next class, we will start with the statistics, and after that statistics, we will start our revision classes. So there will be test and then revision, test and then revision. This is the way we are going to do till your board exams. And start doing revision on your own also, and start sending me questions if you are having any doubt in any of the question. Is this clear to all of you? Okay, so that's all for today. So let's wind up our class today. So that's all for today. We'll meet in the next class. Okay then, bye.